down my video just to save bandwidth here.
Sure, please. Okay, guys. Thank you everyone for joining in. It seems there is some issue with the tool today to join people, so we are having some issues there. But that's okay. We are also doing the live casting at YouTube, which the link I have given. So I think we should be good. So thanks again for joining in, guys. So let's get going. This is the seventh meetup what we are doing in the Kubernetes in the Cloud Native Online Meetup, which we run from Bangalore. So in this meetup, we are going to first cover Envoy, which I would cover for around an hour, and then we'll have Christian Costa, who is going to cover Envoy powered API gateway, Gloo. Yeah, so that's me. Quick intro about myself. I am founder of Clouduga, and we provide training and consulting in the area of Kubernetes, Docker, and so on. I also authored the official Kubernetes course for CNCF, which has been taken by more than 100K participants. I'm also a CNCF ambassador and CK certified as well. Before starting Clouduga, I worked for Red Hat for a long time, and where I did played different role there. And I wrote a book on Docker in 2015, which is kind of 5 years back now. And before running this meetup, I also ran the Docker meetup group in Bangalore as well for some time. Okay. So the agenda for today's my session would be we look at the overview of proxies. We would then see how the communication happens between the microservices into Envoy, Envoy topologies, what terminologies you have for Envoy, some of the configurations for Envoy, and then we'll do, I think, 6 to 7 demos which I have planned. So that would be interesting, I believe. Let's get going. So what is a proxy in general? If you kind of look at the term proxy, it is like authority to represent someone else. That's the general terms what we have. So what you see on the screen is, for example, there are two hosts that they have to communicate, and host 1 and host 2 can communicate without knowing each other if there's a proxy in between. So host 1 communicate to the proxy, and then proxy would take the connection back to the host 2, and then vice versa there. So host 1 just send a request, and then somehow it gets a response back. So there are two kind of proxies are there. One is open proxy. It has two types. One is anonymous proxy, in which what happens is the server does not know who is the originating client IP. So if there is a server on the internet which is there, and there's a client, and client kind of want to access the website, and if it uses a proxy in between, which is anonymous proxy, then anonymous proxy would kind of take the connection and give it to the host or the server on the internet, and the connection would happen, but the server would not know what is the IP of the client there because the proxy in between. And then we have the transparent proxy, in which the proxy discloses the IP of the client as well. So depending on your use case, you would kind of configure either anonymous or the transparent proxy there. Then we have reverse proxy. So in the previous case, we kind of try to hide the client IP here. But in this case, we do not tell that who is my server. So this is called reverse proxy. So in which the client is communicating via this proxy here. And proxy would kind of give the reply back from any one of these servers which is running behind the proxy there. So, and anybody can respond back. So that's a reverse proxy for you, that in this case, we are hiding the details of the servers. That's why we're calling it as reverse proxy here. So what are the use case of reverse proxy? For example, we can use it for load balancing, SSL termination, security, caching, compression, and so on. So for all that purpose, we can use a reverse proxy. And this has been very widely used in the environment. I mean, in typical internet or in the companies, you will see these are very general things what we do these days. Okay, so what kind of software you can use for proxy? So some of them you can kind of host yourself, like Nginx, HAProxy, Envoy. These are them you can kind of configure on your own. And then also you can take it as service. So some of the companies provide it is a service. So for example, if you're in a country where some sites are banned, right? But you can access a proxy server. So via the proxy, you can access the respected web, the website you communicate to, and the proxy would kind of take care of that. That's like the software point of view there. Now, why proxies are important in the today's microservices world? So let's try to cover that part a bit. So generally, we assume that if I am on a service, for example, I am a front end, I want to communicate to backend or any other services behind the scene. Generally, we assume that okay, it might be just one hop away. I can just make a call to service B, and I would just kind of reach to service B. But in the real world, this might not be true, right? Because the service B can be in different cluster, region, or a different cloud. It can be anywhere, right? For a service A, just want to communicate to service B. That's what we make a assumption there. But things would play in between. And what can happen is there might be multiple instances of service B also. So which one you would connect to also, right? How do you load balance between them? So these are things which you have to take care in the today's scenario of microservices there. Apart from this, we also need to handle like timeouts, retries, authentication, circuit breaking, observability, and other protocols which you might have in today's world now, right? So how do you handle all of these things where I need to kind of say if I'm going to communicate to service B, and if service B fails for the first time, I will try a couple of times. That's called retries, right? So I want to kind of do that. I want to implement timeout, saying that okay, I need to get the result within a specific number of seconds. So how would I kind of get that stuff there as well? So all these things you have to kind of implement in the today's microservices world. So how we can kind of handle all of these things? So one way is that you implement a language specific implementation, right? So for example, you can kind of say, okay, I would writing all of my code in Java, and for the Java specific language, I would kind of use the tools which are listed here, mostly from Netflix. They have built these tools to kind of get the specific functionality which we are looking here, timeout, retries, and so on there. So you can use this language specific stuff there and achieve the things. And it has happened before, right? So Java has kind of had all these things and we could do with this thing. So, but this does not look in the current scenarios, right? Because we write our code in different languages, right? And we have different platforms to deploy the applications and so on. So this might not fly in the today's world, right? So what we can do is we want to have something which is independent of language and platform. So I want to have service A and service B, but I want to have them communicate such a way as transparent for them. So service A saying that I want to communicate to service B, but in between if we can implement some kind of proxy or a layer which gives me all the features which I mentioned, timeout, circuit breaking, and so on. So if I have all of these features in place by this proxy, I can transparently put in front of any service which I have. And that's what Envoy is. So what you do is you basically, if you talk about in terms of Kubernetes, right, you might know about sidecar containers, right? So I would deploy a pod for my primary app, and along with my primary app, I'm going to deploy a sidecar proxy. And that proxy would kind of implement the features without telling what the pod service is about, right? So basically you deploy any simple app, but you put the sidecar, and that sidecar would take care of building all the features or like circuit breaking, timeouts, and all that stuff. So that's what Envoy is, and Envoy is being used in service meshes very extensively now these days. Yeah, so let's look at some of the features of Envoy, and then we'll dive deep into it. So it is out of the process architecture, which means your app does not need to worry about anything at all. All the features would come and build with Envoy, and you just attach it as a sidecar, and that's it. And your app need not to change anything at all. It just run plain, right? Whatever app you have, it will just run as this. It's a modern C++ code. We can have different filters with L3, L4 layers, which I'll talk about in detail. And then we also have L7 filters, using which I can kind of identify the network packets, saying that this packet is for TCP, this packet for MySQL thing, and so on. So based on that, I can kind of detect my TCP packet or the network what I'm getting, and then I would apply filters on them and then continue from there, right? It has a first class HTTP2 support. Then we have layer 7 routing, gRPC supports, and we have the like specific support like for MongoDB, MySQL, DynamoDB as well. So I'll give you a demo of MySQL today, which would kind of clarify any doubt or anything about this thing. Then we can do search discovery with Envoy. Basically, we can attach search discovery whatever we have. Like for example, if you're deploying on Kubernetes, Envoy can connect to the Kubernetes, and then we can kind of get all the services point via the Envoy and so on there. And there are different ways you can have search discovery with Envoy, which I'll talk about. You can configure this thing as a front proxy or an edge proxy. So for example, if you have a network and the traffic is coming from there, you can have Envoy sitting on top of that network, and all the traffic goes in from there. So let's talk about some topologies using which Envoy can be configured. So one simple thing is you can have it as an ingress and egress, right? So any traffic coming to your application can come via Envoy. Similarly, any traffic going via the application would go via Envoy. So Envoy can kind of do it both ingress and egress for you. Then you can do load balancing with Envoy. So basically, if you have multiple replicas of your application, then Envoy can kind of load balance between them. You can configure Envoy for your ingress and egress. So as I discussed, right, if you have your network and you can kind of put Envoy on top of that, so all the traffic can come via Envoy, and then similarly you can have all the egress rule. So all the traffic would route via the Envoy as well, depending on your configuration. You can have a setup in a hybrid mode as well, where you can have, of course, ingress, egress. Then you can have load balancing also happening with Envoy. And then within a given service, you can also deploy an Envoy, which can have internal communication between the services as well. So you can configure Envoy in different topologies, what we are seeing here. And then you can have multi-tier setup as well, where you kind of get the traffic from one of the Envoy ingress, and then you can have multiple Envoys in place. I mean, depending on your use case, you kind of use this feature here. And then from those Envoys, the traffic can kind of get into your services in the back there. Okay, the architecture of Kubernetes, the architecture of Envoy looks something like this here. So what happens is when you kind of make any connections to your Envoy, you create a worker thread to it. So a worker thread would kind of take that entire connection from in to out. So that's kind of a thread kind of takes care of that. And then what we have is something called as listener here. So any traffic coming from a downstream. So downstream is nothing but your user, for example, your browser or your any other service which want to kind of come and communicate to your app via the Envoy, that becomes a downstream for you. So from this, you kind of get into your Envoy, and then you would kind of have these listeners here. This listeners are nothing but it can be any port number or socket thing, using which you will kind of get into your Envoy chain there and Envoy thing. And then with this particular listeners, we'll talk about filter chains. So you can have multiple filter chains. For example, you want to first detect the MySQL filters. Okay, are there any MySQL packets there? And you want to say, okay, I want to look at the TCP stuff in that. So you can kind of configure them in different filters. And once those filters are being passed, you would kind of send your stuff to clusters. So clusters are nothing but collection of multiple of your endpoints. So for example, yeah, let's talk about those things in a minute. So you can have a cluster, nothing but logical collection of one or more endpoints. Those are called as upstream. So upstream is something which is your end thing. So for example, if you're running a pod or a container, that become your upstream. So your connection come from downstream, which is your client, and then whatever is your server or serving entity that becomes upstream for you, right? So I'll kind of go detail in each one of them in a minute. Okay, so let's talk about listeners now. So listeners are nothing but your endpoint to which you will connect to. So for example, if you configured an Envoy, and you can have multiple listeners here, that one can, let's say, listen on for HTTP only, other listener can listen for TCP. So those kind of you can have. And it would create the connection and pass the request to filter chains. So filter chains are like this. I'll talk about this in a minute. These are filter chains. You kind of go one by one filter, and then from there kind of get into your clusters and so on. So what's happening here is you kind of put down a listener here. Like here we are saying my listener here is going to bind to all of the IPs on my system on port 8080. So if I'm making any connection on my host system, whatever where I'm running Envoy on port 8080, I'm going to hit to one of the listener here, whatever has been configured there. And remember, I can have one or more listeners here. Okay. Then from the listeners, listeners would have few filter chains here. Like filter chain, nothing but your packet comes in, somebody has to kind of look at those packets, see what's in it, right? And what you would do with that. So for example, you are saying that, okay, if I'm getting an HTTP packet with some host header, I want to change it. So those are kind of the filters you would write here. So anything you want to change, or you look at the packet, the network packet, and you identify what kind of packet is this, and then you kind of do something on that, right? So for example, here on the left hand side, you see there's a filter chain here. In this, I have two filters here. One filter is for MySQL, another filter for TCP. So I would have like one filter here for MySQL. So I'll look at for MySQL stuff, and it will tell me what to be done with that MySQL packets if there are any, right? And I'll see if with that TCP thing, what should I do with the TCP stuff also. So I can write these multiple filters one after another, and eventually from that I would go to clusters. So that's about clusters now. So clusters are nothing but collection of similar upstream hosts. So for example, you can think of a Kubernetes service can be a cluster kind of stuff, right? So a cluster would be like that. So like here, what we are saying, I would come to the listener here. I would go over my filter chains here. Then I would hit to clusters here. Now here, if you look at the cluster is like a block. So for example, suppose you are on Kubernetes and you deployed a WordPress app, and there is a front end and the back end. Front end is with your WordPress application, and the back end is from MySQL, right? So one cluster I would have of type block, which would connect to my block service. I have one more cluster called MySQL cluster, will talk to my MySQL endpoint here. So you kind of come in, go via the listener, then filter chains, and then you will kind of come to your clusters. So clusters are independent of listeners. So I can have clusters of different types, and from my filter chain, the traffic can go to any one of these clusters. And after that, I would go to endpoints eventually. That what is my endpoint towards the end, where I will connect to. So endpoint is where exactly kind of go and hit. Like in this case, the endpoint is the WordPress and the DB app. So what's happening, suppose this is being deployed on Kubernetes. So we would have a server discovery within Kubernetes itself. So the Envoy can connect to my Kubernetes and then find out what kind of services I would have there. And depending on my configuration, I would kind of communicate with them. So here I'm going to kind of connect to my WordPress or the DB service, and eventually then the backend I would have these pods, what I have typically. So, but for an Envoy here, the endpoint is the service to which I would communicate to. So my traffic comes to my listener, I go over the filter chains, then I would kind of, based on the filter chains, I would go to the specific clusters here. And then from the cluster, I would kind of get into the respective endpoint here. This might not be very clear now, but let's look at some demos and they'll become much more clear here. Okay. So for now, we talked about a few terminologies here: listeners, filter chains, clusters, and endpoints there, right? Now, how do we configure our Envoy for doing that thing, right? I can kind of either always build this kind of entire stuff manually, where I start with listener, I would define my filter chain, I would define my clusters, and from there I'll go to my endpoints there. So I can do all of this thing configuration manually, right? That's one. Or I could kind of do it dynamically. That's what we call as XDS. So as you would know that we use Envoy heavily with Istio. And I'm not going to write any one of this configuration file, which I'll show you in a minute, manually, right? So there should be some way by which I would configure these things dynamically. So for that purpose, Envoy gives you this XDS endpoints, and we have different discovery services for that: listener, route, cluster, and endpoint. And basically, I would kind of make the calls to these discovery services, and then I would kind of build my Envoy flow dynamically there. So what kind of discoveries I can have? So when I am deploying Envoy, how can I discover my endpoints there? So there are different ways for doing that. One is the static way for sure. You can statically configure all the routes. You can configure with strict or logical DNS. So for example, if you kind of hit a URL, for example, google.com, and that gives you, let's say, multiple IP addresses back. So how would you kind of take them as endpoint to your service? So those kind of things are kind of defined here. And then you can also always use this discovery service for sure. And you can write the custom clusters also if you want to kind of have a custom logic to make your cluster creation. So cluster, I mean here, how I define the logical collection of my endpoints. So let me see if there are any questions now. There are a few questions coming on the screen. Sure. I'll take them in a minute. Maybe let's take them now, right now. Okay, the question is helping. Okay, that's good then. Let's continue here. Okay, so this is how the if you put together everything, this is how it looked like. It would look complex now because we're just kind of getting started now. But if you kind of pay attention a bit, I talked about few terms. Let's try to kind of put them here. So you have a worker thread. The traffic comes with the worker thread. Then you would have listener filters here. With those filters, you would create a connection. And then you will go over to multiple chains here of filter chains. Then there are read filters. You would read whatever the filters are there. And from there, you kind of go back to go to your HTTP based connection manager here. So one thing I missed here actually to talk about briefly on that. Yeah, so of course we would have these L3, L4 filters. We also have one specific filter called HTTP connection manager, because HTTP is very important part of our day-to-day life, right? So they have specifically built an HTTP based filter which can which further has HTTP only specific filters. So you have an HTTP connection manager which has HTTP specific filter also. So I'll talk about that in a minute. So that's what this HTTP7 L7 filter here. And from there, I will kind of go to the read filter of HTTP7 or sorry L7 here. Then I would kind of go to my backend service. From the backend service, my traffic would come back. I would go to the write filters, then come back here, and then again I'll come back to the write filters of L4 layer and come back. So that's how everything kind of works together there. Okay, so now we look at different demos. So let's kind of see that in place now. This would be most interesting section, I believe. So let me just get the screen right here. Okay, just a minute. Okay, so what you see on the screen, this is something, this is a tool what we have built for our training purpose, but you can completely ignore that. What's happening here is, whatever the stuff I'm going to do it here, that is going to run on my Docker desktop. So for example, if I kind of run any command here, just want to tell you that how the workflow going to be. So if I do anything here, so any commands I'm going to run here, these commands are going to actually run on my Docker desktop, which is on my workstation there. So that's how it is going to run. What happened? Yeah. So that's all there. And so I'm going to kind of go over these demos here. And with these demos, I would kind of connect to my Docker and the Docker desktop running on my workstation and do the labs there. Okay. So let's look at the first demo here. So what you want to build a simple TCP proxy in which I want to kind of make a connection to my Envoy here. So let me show you the config file. Yeah. Yeah, so let's open this config file, try to understand what's happening here, and that will kind of uh, help you out. Yeah, so what we discussed first is I want to kind of build a listener here, right? So here what I have is I have, first of all, I'm building this statically. So I'm going to put a static resource here because I'm not building it dynamically here. So now I have a listener here. In this listener, I'm saying go and connect to any one of my IP address of the host on port 8080. So I have defined a listener here, right? Then I would define a filter chain, right? So let me define the filter chain. So then I'm saying I have this filter chain and I'm putting a TCP proxy as my filter chain. So I'm going to kind of look at all of my TCP packets coming in onto my environment, right? And then what I define, so what we have done is we have defined the listener, we have defined the filter in which I'm saying I want to look for all the TCP packets. Then if you look at here, we are defining the web. So I'm saying look at the web cluster. So I'm creating a web cluster here. So we are saying any packet which is coming via this filter has to go to the cluster called web. So that's what we discussed earlier, that the traffic would route from filter chains or a filter to your cluster. So here I've defined only one cluster called web, right? So here is only one filter of mine called web. From here, I have defined my endpoint. So what we are saying, if my traffic is coming to this web cluster, I would route it to two of my endpoints. So I'm saying that go to either the endpoint called service one or go either to the endpoint called service two. So look at what's happening is my traffic is going to uh, come into my Envoy. I would look at, I will listen on port 8080 here. Then from there, I'll see the TCP packet. I'll go to the web cluster. That cluster has two endpoints. So whenever my traffic is going to come from my downstream, I'm going to kind of switch between service 1 and service 2 as I kind of do that, right? So let's do that. So this is what your configuration file looks like. So now I'm going to kind of go ahead and run these things. So I have used the Docker Compose file. Docker Compose file, we have kind of put these things in place. Come on. Yeah, things seems to be up, but yeah. Okay, so it's kind of building that my Envoy thing configuration there, and then let me just do the PS here. I think we're going to be there. Let me just wait quickly. Okay. Now what I need to do is I kind of want to kind of go and access these URLs from my workstation here. So I'll kind of come to my workstation here. Let me bring a terminal on the screen here. Just a minute. Where is it? Yeah. Why it is not coming? Just yeah. Sorry about that. Yep. Yeah, so what I'll do is I have kind of made this thing up. Now I'm just going to do a curl multiple times on that URL here, which is here. So as you will see that as I want to do the curl on multiple times on this URL here, uh, happened localhost. I did not make the application up, I believe. I just made that build here. Come on. Yeah, so it's going to create that one. Meanwhile, let me just start doing the curl here. Let's see if that will come up. Why it is damn so slow? Come on. Let me just kill some of the processes which I am not using now. Let me just use this one. Sure. Oops. Come on, everything is ready, but this is demo gods does not come with. Come on. Okay, so I think I'm just going to wait for that. I want to kind of continue fast. Okay, so let's, or at least, come on. Oops. Okay, I think I'll just maybe give it a minute before I kind of go over all the maybe demo screens there, and then we'll kind of try to run them one after another. Okay, fine. So this is what I wanted to kind of show you with TC proxy here. I'm just really not so convinced that why it is slow. Okay, let's I think give it a minute or so. So in this demo, what I wanted to show actually is that you hit the downstream, you go to a TCP filter, and then from there, we'll hit this web cluster, and my traffic would switch between two services. So I have configured an Nginx here and one HTTP bin here. So my connection would kind of switch between those two services there. So the first demo I want to kind of show there. Second example, I want to kind of show that with the help of HTTP filter here. So again, we have two same services here, but instead of hitting the specific URL only, I would need to hit a /service or /service2. Based on that, I will go to the right endpoints of mine. Okay, so let me show that here. Okay, at least let's go over every configuration file there if it's not working there. So yeah, so let's go over the HTTP thing one. So I'll go to configs here. Then I'll look at this Envoy configuration here. So what we are discussing here, the HTTP filter using which I want to hit my URL /service1 or /service2. So what we are saying in this case is, let me come into my Envoy with the listener. From there, I would look at the match here. So what happens is, you would have this route configuration here, and in which if your prefix is /service1, go to cluster called service1. Similarly, if your match is /service2, you will go to the cluster of service2 there. So that's how it is going to work out, where depending on your suffix of the URL, you will go to the right cluster, and in the cluster I would have these different what do you call the endpoints here, which is going to be my service 1 and service 2. So the way it has been configured is I have this Docker compose file. In the Docker compose file, I'm creating this Envoy container. Then I'm creating the service 1 and service 2 here, right? So as you can see that if I'm going to come with my Envoy, I'll go to the service 1. If I hit this one, I'll come here. If I go to service 2, I'll come here. So that's how you would kind of do that. So we'll hit a URL /service1 and service 2. That is about your HTTP proxy there. So yeah, this is up now. So let me quickly do a curl here. Yeah, this is the TCP one. So let me just quickly go to the previous slide here. So here, if I kind of hit my Envoy on this 8080 port, I'll go to any one of my services behind the scene. So like, as you can see that if I hit this one, I am going to get Nginx. Then if I hit again, I would go this HTML code for HTTP bin here. So if I kind of try to come here and hit localhost on 8080, I'm going to get this page. And if I hit again, maybe because of the caching, I'll not see that. But if I hit on incognito mode, and then if I hit localhost 8080, I will get the other page, right? Depending on which one you will hit, you will get that stuff. Good, so at least our one demo works. So let me bring it down. Okay, let's go to the next one. Yeah, we have some time left. Hopefully we'll finish all the demos here. Okay, I think it's not going to work out. Let's continue further. The other example which I had with the help of front proxy here. So what we're trying to configure is I want to kind of get my connection in from the external world via the Envoy, and then I would have Envoy within my application as well. Like you have a sidecar which contains your Envoy as well. So what's think about this particular is your entry point for your network. So my traffic would come in to this Envoy here. Then I would have the filter chains for that for HTTP. then I would kind of go to my app, which contains another Envoy, and from there I will go to my Flask application there. So that's how the traffic is going to look like. So let me quickly show that thing for that as well. This is done. Hopefully, for example, this will go up also. I'm really sorry that some of the system is behaving not as expected, and then it's kind of creating all the problems. Okay, I think just. Okay, so that is the front proxy for you. Hopefully this makes sense. You kind of configure a proxy in front of your cluster, and from there will come in. If I could show the demo, that would have been really good, but yeah. Okay, then if I would have scaled one of my service with Envoy here, then what would have happened is, in the previous case, if I hit /service, I will get the output from this particular application of Flask. And if I hit my port 8080/service2, I would get served from here. So these are two my different endpoints for these applications. Now what I'm saying is I want to just scale my service one here. So now my service one would have 3 endpoints of its own. So if I hit this URL /service1, then I would get a reply from any one of these. That is what I want to kind of showcase here, that you would kind of try it out with the front proxy scaling there. Then there's one more example. Let's see if I could have. No, that's okay. The other example which I want to kind of show is with the help of tracing. So as you know that you can have the tools like Jaeger and so kind of stuff there, using which you can trace your entire workflow, right? So for example, if you have a microservice-based application and your traffic come into your cluster, and then you want to kind of track where the packets are or where my request is going. So there are tools like Jaeger and Zipkin, which can help us trace that. But they need some input data, right? How they will kind of build the graphs for you. So for that purpose, you would kind of, again, use Envoy for that. Envoy has this Jaeger filters or tracing filters inbuilt. And with those filters, as the packet comes in, you can put a kind of stamp on that. And that stamp you can kind of watch across the network and see what's happening there. So for example, if I want to quickly show the thing for that, so if I kind of come back here, and so the example of thing here. Okay, let me talk about maybe front proxy first. So I mentioned about there are two kind of proxies are there. One is at the front. So this is the front proxy, if you kind of imagine that. So from there, my traffic is going to come to service/1. I'll go to service 1. If my traffic is coming to this port IP on service/2, I'll go to this service. That's right, traffic is going to come in. So from here, as I told you, I'm going to kind of go to one more Envoy here. This is, I came here. Now from here, I want to go to my other one. So if you look at the way it has been configured, so if I go here, this is my filter for that. So this is HTTPS1, but that's okay. Yeah, this is my cluster for my service one here. And now if I look at from this, I would go to my service one container on port 8000. And if I look at the service Envoy there, now here I would have one more Envoy configuration. So I'm saying that any traffic coming on port 8000, take it to my local host on port 8080. So that's how it's been configured there, that you kind of come here and then from there you go to the port 8080. right? That's how the front proxy can be configured. And then if you scale up, you will see that behavior as well. So for trace purpose, what I want to kind of show you. So if I look at the trace one, configs, and if I look at the compose file, so there I would have a tracing filter. So I'm enabling a tracing filter here, which would basically kind of help me out to figure out, get those stamps sent across the network, which I can then collect it with Zipkin and then showcase a complete flow of my calls there. I want to kind of give you all the demos there, but somehow it's not possible today. Maybe I'll record it and share it. Okay, the last example which I want to give you without taking so much time, that if it's possible, let me just quickly see if I can just have it demo running for you. This is a very interesting demo which I have built. Let me just do it here itself. Okay, so anyway, what's happening in this case is I have deployed a WordPress application, and for that WordPress application, I'm also definitely doing that HTTP one, but I also want to show it the MySQL filter, that how does the MySQL filter can work with our application here. So if you look at what's happening is I have deployed 3 containers. If you look at that way, a WordPress container, a DB container, and an Envoy container. So what I want is I want my traffic of the HTTP would come from my Envoy over HTTP. From there, it would go to my blog cluster, which has my WordPress configured. So for that blog cluster, the endpoint is my WordPress app. Now, I'm not making connection from WordPress to the DB service or DB container just like that. What I'm saying is WordPress go and communicate to my another listener on the same Envoy. So I have 2 listeners here. One listener on port 8080, other listener would be on some other port, like I think 3307. So I'll send my traffic there, and from there I would send the traffic to my DB. What is the benefit of this? I'm going to kind of collect all of my MySQL thing as well, or what are my metrics for my MySQL as well. And then I can kind of see how much my MySQL behaving there. So I can have filters like this for MongoDB and so on. So I hope this would come in. So yeah, I really don't know what's happening here today. Okay, I'll try to see if towards the end I can show the demo for that. But that's how I kind of show a demo for you for this thing. And we've also configured a Grafana and Prometheus for that. So I can kind of really show the plot for you that if I kind of make a query to my WordPress, I get the Grafana dashboard for that. So I'll try to cover that maybe towards the end of this, after the Christian session. If possible, I could get it running. Are there any questions for me if they're not being answered there? I think there are a lot of.
I tried to keep up to help you out here.
Okay, thank you. But if there are any questions left for you guys, just put them in the chat. Thanks, Christian, for helping me out there. I'll try to kind of see if I can show the demo towards the end of your session. So I think you can take over now, Christian, and then maybe I'll try to show the demo towards the end.
Okay, thank you.
Thank you. I'll share my screen.
Yeah. Here, and maybe I'll turn the video on just for a few moments. You should be able to see my camera, right? Share screen. Okay. Do you see my screen?
Yes, we see, Christian. Yeah.
Okay. Wonderful. All right. Yeah, you can see behind me. I'm prepared for the worst. All right. First of all, thank you all for having me at this meetup. I'm excited to talk about these technologies and Envoy, and the presentation that you had there about Envoy was perfect. You know, it gave people an idea of what it is and what it takes to configure it, what are some of its capabilities, and so forth. So my name is Christian. I work at a company called Solo.io right now. Been here for a year and a half, or a little over a year and a half. Before that, I worked at Red Hat. Before that, I worked in at an open source integration company called FuseSource. I've been, and before that at enterprises and so forth. I did spend some time at Zappos.com, where I got to work hands-on and up close with Amazon and Zappos at the time, right? And got to see what DevOps and microservices and all this stuff was before it became all this, trend in our industry. This was back in 2012. And from there, I built a lot of understanding of how this stuff works at a high web scale company, and some of the maturity around their automation and the processing and so forth. So I've through my work at Red Hat, working on early days of Kubernetes, very, very early days of the Istio project and so forth, bringing this type of infrastructure both into open source and to enterprise and to companies to help adopt that. And so when I left Red Hat, I wanted to go to a company that focused exactly on this problem, connecting applications together in a reliable way in a cloud environment. And so that's what we're doing at Solo. I've written some books here, as you can see, on microservices and Istio. I'm currently writing the Istio in Action book for Manning. I do encourage you, because there were some questions in here, and just general, I would say, uncertainty or confusion in the ecosystem in general around service mesh, API gateway, Envoy, some of the comparisons between the two and so forth. And I've done my best to try to share some clarifying information. So if you go to my blog, so I've been writing about this stuff. I went back and looked, since the very beginning of 2017, specifically about Envoy and this technology. So if you click on that, so I wrote this blog about Kubernetes and Envoy and gRPC as being kind of the next. So the open source projects that are kind of leading the way to bring what I saw at Amazon and the web scale companies into open source, and to enable people to build cloud applications more successfully. So like I said, check out some of these blogs about Envoy, and comparing these things to API gateways and ESBs, and actually putting them to work in a microservices environment, reducing risk and so forth. So take a look at that. Reach out to me on Twitter. I also share videos and blogs and updates on my book and so forth on Twitter. So, but I'm happy to be here talking to you. Like I said, I work at Solo.io, whose mission it is to build this application networking infrastructure to allow services to talk over, when deployed in cloud environments. So if you just take a look, for example, at Kubernetes, right? Kubernetes is, kind of won the container orchestration wars, but what is it? It's a foundational layer for deploying containers. That's basically it, right? If you want to build any other platform on top of it, you have to build that stuff yourself. But Kubernetes, you take a container, you can start it, you can scale it across multiple hosts. If it goes down, it'll automatically restart it. It can check the health of the container and the applications that are running in it, regardless of what's running in it, right? So Kubernetes is a foundational deployment platform. Once you put applications into Kubernetes, these applications need to do things. They need to talk with each other. They need to implement some level of reliability and security and so forth, right? At the application layer. And so that's where technologies like Envoy start to come in and fill the gap, right? So it's a layer on top of Kubernetes. And Envoy by itself, as we saw, is very powerful. But Envoy itself isn't the final solution, right? The goal is to build ultimately your platform in such a way that you can deploy applications regardless of what language they're written in. Kubernetes, something will manage them, deploy them, scale them, keep them up. But something also allows them to talk over the network reliably, resiliently. We control the routing, layer in the security, independent of applications, like we saw in the previous presentation. And very importantly, understand what is happening between the applications and on the network. So Envoy is this little piece that can help build this application networking abstraction. Right. So now, what is this application networking abstraction? Some of the important pieces to this is it needs to be decentralized. Right. We've seen in the past application networking, kind of functionality in terms of, let's say, messaging-based systems, message brokers. Right. With message brokers, you could kind of get a decoupling of the caller and the server. Right, you can get that transparency. So it's kind of like service discovery because you don't know exactly where the server is. You get things like reliable, to an extent, delivery, retries, and load balancing. Right, you connect multiple consumers to a queue. You can get load balancing and so forth. But it's highly centralized. Same thing we saw with the ESBs that were built on top of messaging brokers often, or API gateways. Right, we said let's build APIs, expose this on the API, economy, and do all this stuff. But what ended up people really doing is taking an API gateway, putting it in the middle of their application architecture, because it can do security, because it can do some routing and self-service and so forth. They put it right in the middle of their application architecture. Everything went through this API management solution. And so what we're trying to move toward when we move to cloud is decentralized processes. All right, GitOps, these types of workflows were more highly centralized teams that run you want to make a change, you have to file a ticket and so forth. So we want to build this. So the problems are not all that new, but the implementation for how we build this in a highly decentralized, highly ephemeral cloud infrastructure where nodes could be coming and going, pods coming up, scaling and so forth. The implementation needs to be decentralized, and it needs to be amenable to decentralized processes. So the people, how do we organize our people, and how do we use this technology and so forth? So coming back, Envoy provides the kernel or the foundational component to building an architecture that ends up solving those problems. And so that's what we're going to look at today, and specifically some of the things that we're doing at Solo. So why Envoy? I saw some questions on the chat there. Why Envoy? And the answer is pretty straightforward, actually. The number one thing is the community. The community has kind of come around and coalesced around Envoy. The innovation in level 7 application networking technology is happening in the Envoy community. And it's happening with input from massive companies like Google, like Apple, like Verizon, and you can see Amazon. You can see some of the people on the right hand side of the slide, right? So the innovation that we saw at Google is being poured into Envoy. The innovation at Netflix and eBay and so forth that's kind of the central place where people are coming together to push on this. And we'll look at some of the fruit of that innovation in a second. The second thing is very, very important because not every single architecture is exactly the same. So Envoy was built from the ground up to be highly dynamic and extendable. So we saw some of that in the previous talk, but this is a foundational piece. Being able to extend Envoy and a community that will help you do that is incredibly important, because we want to support all these different technologies. We want to support all these different use cases, but we want to allow extension points and APIs and make a modern code base that enables that extension. So, for example, an example of this innovation and extension in Envoy that's happening right now is around WebAssembly. So WebAssembly, which kind of grew up in the browser, is a way of dynamically injecting your custom code into a target endpoint, either the browser, or in this case, Envoy. So we can extend Envoy writing WebAssembly, or writing WebAssembly. You can write in any language, and it compiles down into WebAssembly, and then you can deploy that into Envoy, right? So you can make some people in telco have these highly custom protocols, or you need a certain logger for your access logs, and so extending Envoy has been a foundational principle from the beginning, and you used to have to do that by actually extending the C++ code, but now you can just do it with WebAssembly. The last thing, which was definitely touched upon in the previous talk, was it was built to be dynamic and to change and to be driven by an API, not file configurations and hot reloads and potentially dropping connections, and but where we didn't have this dynamicism 20 years ago, right? Envoy was built from the ground up, as we saw with the different XDS services. So it's basically Envoy talks to an API, gets the information about what services can it route to, what are the routing configs, what are the security policies, and so forth, and can change on dynamically, right? So now we see some of these other things, very deep telemetry collection and so forth. So using those principles as the foundation for Envoy, we can build pretty powerful networking technology. So let's take a look at what that might look like. I think I'm on this. I know I'm on this. Sorry, I'm going to bounce around a little bit because I want to tell a story naturally, and I'll use the slides to help. But I want to just I want to speak freely here. I'm just bound to a single slide deck. So, what are some of these challenges? What are some of these connectivity challenges? How would Envoy fit into this picture at all? And this is something that we take. This is core to our ethos and our competency here at Solo, which is our background is in Envoy, deploying and running and managing Envoy in production at scale. But some of these networking challenges we talked about earlier, right? A service talking to another service is rarely that simple, right? You're rarely talking directly to that service. You're usually talking over the network through multiple hops, different boundaries, firewalls, and so forth. And these networks are not reliable, right? So that's not new information. But so these applications have to solve for things like timeouts, retries, circuit breaking, and so forth. Now, if you deploy as we start to go to microservices and so forth, Kubernetes, and you start to deploy these applications into these types of cloud platforms, right? You need a way to allow traffic into that deployment system, that architecture, without it being haphazard and just coming from all over the place, and not being able to enforce good practices around security and so forth. And so you might not be trusting the callers that are calling into the system, and you might want to expose your services, a little bit different than how they're actually implemented and so forth. So you need things like transformation. You need things like authentication, authorization, policy enforcement, and so forth. And some of these APIs you might want to expose, and you might want to catalog, and you might want to have searchable and so forth. So self-service sign up and documentation and automation around this is important. And then you take that problem and say, well, there's not really just one boundary, right? We have maybe multiple clusters of Kubernetes, or maybe running on premises, or running in a public cloud, or both. Maybe in some cases we've talked to lots of large companies that are actually running in multiple clouds. So this is not a, well, let's just solve the problem once and we have it solved, right? There's multiple areas. All right, and so now how do we expand that and be consistent when we configure? How do we federate the different services that are running in this so we can treat this as a single large architecture? And it starts with Envoy. Okay, so before I get into this part and Gloo, I want to come to this slide. Envoy, right here. Envoy is incredibly versatile and can be run all in various parts of your architecture. Envoy can be used to solve problems at the edge, which we're going to look at a little bit closer. Envoy can be used to solve problems as a shared proxy or boundary proxy within your architecture. All right, so maybe a group of services that all live and work together, they share an Envoy when they talk out to the network or when requests come into them. And then lastly, with the hype around service mesh, you might recognize this pattern as well. Envoy can be run right next to the service itself and perform duties on behalf of the application. So it's effectively part of the application. And the traffic goes through it when it's leaving the application. Traffic goes through it when the application is coming, or traffic's coming into the application. You can kind of think of it as an interceptor of the networking traffic for that particular application. So Envoy is incredibly versatile. But the scenario that I just presented, where you start to say, well, how do I get traffic into my clusters? That's where Envoy fits as an access proxy or an edge proxy or an API gateway, whatever term you want to use. But you need to solve the challenge of that traffic coming in to your service deployment, service footprint, right? And so at Solo, we built an open source project and an enterprise product around that particular use case, that particular role. We call it Gloo, and I'll talk about Gloo in a second. But we, and then we built a developer portal on top of this. So with this Envoy-based infrastructure, you can have a developer portal and so forth. We're kind of helping drive the community. We're working very closely with Google and helping to drive the community in the direction of WebAssembly and WebAssembly adoption. So we'll talk a little bit about that. But like I said, once you start to deploy across multiple different footprints, whether that's on premises in Kubernetes, in AWS, or any cloud, you still have this problem, and you want it to be decentralized. You don't want to have just one centralized gate where everything goes. Ends up being the bottleneck. What you want is decentralized implementation, but you do need a level of centralization in terms of configuration management and policy authoring, right? So you need to be able to solve for the problem of federation. And so we'll talk a little bit about that as we go. Now, this problem doesn't just stop at the edge. This problem also exists between applications. So if you scope the boundary down to, instead of a group of applications, a single application, we still have some of these same problems. They're not exactly the same, but there's some similarity and overlap. And so that's where you start to push Envoy down into the services themselves, and that's where the service mesh concept starts to take hold and start to fit. But again, we run into the same problem, right? Across multiple footprints and trying to federate across these different deployments. That's a difficult challenge. Again, these are all things that Solo is solving, right? This is what we're building our products to do. This is our core company. This is what we are focused on. And ultimately, across this type of hybrid, highly distributed environment, we need to be secure. We need to be able to observe the traffic and understand what's happening. We need to be resilient and provide smart failover, and we We need to be able to extend it, because not every organization and enterprise is exactly the same. So we need extensions, and ultimately we need these APIs to be usable, discoverable, self-service, and so forth. So we're built. This is what we're doing at Solo. This is how Envoy fits in. Gloo is part of that story, but you know, what you're trying to ultimately build is a the solving for application connectivity in a hybrid world, decentralized, and built on state-of-the-art technology that was built to do this. Envoy was built exactly to do and solve this problem. Envoy itself can't do it, but it is a core to that to the frameworks that enable that. So let me switch gears here. So we talked about kind of the bigger picture. Now let's switch gears into Envoy. Go back to Envoy itself and solving the problem of getting traffic into your service platform or service estate, whether that's Kubernetes or anything, right? Anything running in cloud infrastructure. And so that's where Gloo, our API gateway, fits into the picture. And I'll probably go a little bit quick because I want to show demos. But so what is Gloo? I think to understand Gloo, well, the high level it's an open source project. It's built on Envoy, provides API gateway functionality. Now, what is API gateway functionality? Why is that different from just Envoy or Nginx or whatever? And I think the most important part to understand about the API gateway is that API gateway is a role that is played at the edge of your boundary that has a primary purpose, which is expose my services outside of the boundary so that others can discover it and others can use it. And by others, I mean not necessarily the people who built the services. Sometimes it could be, but not necessarily. All right, so there's a level of, first of all, trust that is different between what's outside of the boundary and what's inside the boundary. And we need a component to play the role of providing and coming to terms with that difference. You might have APIs that you expose. Like I said, they might be running in gRPC, and you want to expose them as REST. Or they might be REST inside, but they're kind of an older, maybe say crappier version, and you want to expose something newer and a little bit nicer to your clients and users. Right? So there's this decoupling of what's running outside the gateway, what's running inside the service estate. And so that's where the abstraction part of a API comes into play. The API gateway is an abstraction, first and foremost, between the outside of the boundary and the inside of the boundary. So with that definition, it's an abstraction. We can start to compare it to, all right, well, how's that compared to a Kubernetes ingress? Kubernetes ingress is not an abstraction. Kubernetes ingress just says, here's some ports open and here's some routing rules to allow traffic into the cluster, and that's it. If you're exposing APIs, you're exposing them as is, right? It's not an abstraction. It's just a door to let traffic in, right? Now, an API gateway is probably more like a door with somebody standing there guarding it and saying, you don't need to know what's actually inside. And so to do that, to build an API gateway on top of Envoy, Envoy is a great proxy. Envoy would be great as an ingress controller, which is more like what Contour is. I think somebody asked the question, what's the difference between, what are these things, all these different things. Contour is sort of an ingress built on Envoy, fairly simple, allows you to drive the config of Envoy. But I'm talking about an API gateway. API gateway needs things like transformation abilities. Envoy doesn't have that. API gateway needs things like very strong security aspects, things like web application firewalling, things like being able to plug in with Open Policy Agent, OIDC and OAuth type challenges and so forth. Out of the box, Envoy doesn't have that. So you have to build that into or on top of Envoy to get Envoy to that level of API gateway. And so that's what Gloo is. I just gave a couple examples. There's many more, but that, if you're wondering what is the difference between Gloo and Envoy, is that Gloo is built to be that abstraction, not just a plain Jane ingress controller. It can play the role of plain Jane ingress controller if that's what you want it to do, but it's a little bit more powerful than that. And most enterprises that deploy these applications need that. So as we saw in the previous talk, the Envoy proxy needs to be configured by something. It needs to be driven by something. And earlier slides I showed that Envoy is driven by a dynamic API. Something needs to provide that that capability. And so Gloo comes with Gloo is partly the addition to the proxy, but also the control plane itself. The control plane allows you and simplifies the API of using Envoy. So the API that we expose in Gloo, which let's say if you're running on Kubernetes, is based on CRDs. So it's a declarative format that you might be familiar with. But with Gloo, what we're saying is my use case is to solve the problem at the edge. And I don't really care about listeners and transport sockets and all this stuff that Envoy cares about. What I care about is, what are my APIs? How can I expose them? How can I secure them? How can I build transformations and so forth? That's the API that I care about. So Gloo provides that decoupler, that API that you use, that you write your configurations in. Gloo then takes that, translates it into Envoy, and pushes that configuration out to Envoy. So that's an important part of the puzzle, because Envoy needs a control plane, and Gloo provides that control plane. Now, there's a bunch of other things, but I might just jump into a demo. I saw some questions on the chat there about comparing to Contour and Ambassador and so forth. So like I said, Contour is a fairly simple ingress controller built on Envoy. Ambassador is something that would probably be more comparable to Gloo in the API gateway space, but there is a gigantic difference in the way Ambassador is built and the way Gloo is built. And it comes down to the control plane. And this is a very fundamental, very important part of building an architecture like this. And these are, let me just go here. Why are these hidden? I don't want to skip. All right, skip. We don't want to skip. So with Gloo, I pointed out that the Envoy proxy, as we call it in this ecosystem, is the data plane. This is where the traffic is going, right? Traffic's coming in, Envoy's applying the security, applying the policies, doing all that stuff, routing it to the upstream clusters and backend services and so forth. The control plane is out of process of the requests. Control plane is doing things like discovery, service discovery, right? So Gloo can watch your Kubernetes cluster and know and understand about those services that are running in Kubernetes. It can watch your console service registry. It can watch Amazon EC2, Amazon Lambda, and so forth. And so it can build up this understanding of what services are available to be routed to in Gloo. We also have the translation engine, right? The component that does the translation engine to the proxy. It watches the Kubernetes API if you're running in Kube. You don't have to run Gloo in Kube, by the way. But if you're running in Kubernetes, it watches the API, sees the configurations that you created, translates them, and pushes that configuration down to Envoy, right? So there's a very obvious and significant difference in responsibility between what the proxy is doing and what the control plane is doing. In Gloo, we've built this and separated out these components so that you run and scale and think about the data plane separately and differently than how you run and scale and secure and think about the control plane. All right, it's a very important concept, because when you're running at scale, especially in a production environment, security, scalability, flexibility, these things are availability. These things are highly, highly important. And so that's how we've built Gloo. That isn't the case with, let's say, Ambassador. They have opted and chosen to co-locate the control plane with the proxy. So when you spin up a single pod, if you look inside the Ambassador pod, it's actually only one container. You look inside that one container, and you've got about 6 or 7 different processes, individual processes that are running. One of them is Envoy, and then the other 6 or 7 is this, the control plane part. Right. So if you run Ambassador, you're running the data plane and the control plane in the same application unit. Now, once you start to scale out Ambassador, let's say you have a lot of traffic coming in at the edge, you start to scale it out. When you rev up the number of replicas, you're not getting the benefits of scaling that you're hoping for. Right? You scale up the number of proxies, ideally, to deal with more load. But you're also scaling out the number of control plane components, which you may not need. Or, what ends up happening is in the control plane, just like in Gloo, the control plane needs to talk to Kubernetes API. When you start to scale to meet the load at the edge for your application traffic, you also start to scale inadvertently the control plane and the load that it puts on the Kubernetes API or any other resources that the control plane is responsible for. And this is a very highly coupled scaling dimension that that is not ideal. Even less ideal is that the control plane, like I said, needs to be secured differently than the data plane. The data plane should be locked down with no privileges, nothing, right? It's handling unknown and untrusted traffic. Control plane will have some privilege, but it needs to be treated separately. In the Ambassador case, since they co-locate everything into one container, that container needs access to the Kubernetes API. So at the edge of your system, you're giving the ingress, read-write capacity to the Kubernetes API. If that gets compromised, that's a secure risk or severe risk. And with Gloo and the way we've built Gloo, it doesn't suffer from those same drawbacks. We can scale them independently. The gateway is locked down. There's no read-write going on in the proxy. You don't have to mount the Kubernetes security token at all if you don't want. And then you secure the control plane and scale the control plane components differently, right? The traffic coming into the proxy at the edge might be heavily CPU bound, doing TLS, termination, doing routing, transformations, all this stuff. The control plane is probably going to be doing some CPU calculations and that kind of stuff too, but it'll probably be very memory intensive, right? So you have this very different resource usage and potentially contention that it doesn't make sense to co-locate into a single binary. So there is differences. So I definitely encourage us. I don't want to spend too much more time on this, but there are definitely differences between the, even if they're using Envoy. Like I said, Envoy is the kernel, is the component inside. The rest of the stuff around it that makes a big difference, and that's that becomes very important. So I'll leave it at that. Let's take a quick look at then. So Gloo is, like I said, an open source API gateway built on Envoy proxy. Not all Envoy proxies are built the same, but let's take a look at what that looks like. If we come over here, I think here, if we go to solo.io on GitHub/Gloo, you can see that this is the open source project here. So you can go here, you can download, they moved the releases. So you can click on releases and you can come get one of the open source releases. One of the 1.4 line is probably what you want. And then from there, you can go to the docs. And we have a fairly comprehensive docs, setting it up, running it as a gateway, which is the primary way to run Gloo as an API gateway. You could run it as a simple ingress controller, like I mentioned earlier. You could run it in Knative as a replacement for Istio. We were the first API gateway to replace Istio in a Knative environment where for scenarios where you may not need full service mesh and so forth. Gloo Federation is that federation management plane that I discussed, and so forth. So the docs are are pretty good. So you download it. What do? You can install it with Helm. There's instructions in the setup guide for installing with Helm. You can also install it with a CLI, a little helper CLI, and I'll show you that there's a lot of good value and convenience in this CLI. So the CLI is called Gloo CTL. We're actually running a slightly older version. Don't mind that. We have a Kubernetes cluster here, very plain Jane's running on GKE. What we're going to do here is Gloo install a gateway. Okay. So what it is going to do is install the Envoy proxy, as well as the control plane, and some very basic default configuration. And the basic default configuration, we're very security conscious here at Solo. The basic configuration doesn't expose any ports, doesn't do anything. You have to explicitly tell it so that you don't end up in a situation where you've accidentally opened up ports that have exposures or vulnerabilities and so forth. So we've installed our Gloo. So if I do get the namespaces, we should see a namespace there, Gloo system. And K, get the pod from Gloo system. We see we have a couple pods here. We have Gloo, which is our XDS server. Remember, Envoy needs an API, a dynamic API to get the configuration from. So that's this component. The gateway proxy is Envoy. These other two components are supporting the control plane in doing discovery of different services, as well as some transformations of the API, and I can talk about that in a second. Now, if we just quickly come over here, I'm going to use this tool called K9s or K9s. Awesome tool, highly recommend it. It's kind of like a console for your Kubernetes clusters, but we're going to explore things a little bit more in K9s here. So if we come over here to the gateway proxy, and let's say we want to exec into it, and if we do auxiliary or check our process listing, we see that we have a very simple init process, very simple, and we have Envoy. And Envoy is configured using a bootstrapping configuration. So the gateway proxy container here is Envoy. If we come out here and we open up another pane, if we do something like Gloo CTL, what was I going? Oh, okay. So we want to see the proxy. Want to see the proxy URL. Where does the proxy URL live at? Okay, it lives here on GKE. That ends up roughly translating into the external IP on GKE. Well, not roughly, exactly translating to that, right? So we have some convenience commands here. We can do something like Gloo. Actually, I'll show you all the commands here for the proxy. We can get the URL that we just did. We can get all the stats. So Envoy exposes a tremendous number of stats, and what this command will do is go to the proxy and get you all of the stats for the number of calls that have come in, the number of the P99 percentile latencies, and all kinds of. Envoy is very good at keeping quite a tremendous number of stats there. The last thing I'll show just real quick is the log, so we can get the logging directly. We can turn debug on and get the logging from the proxy. So exactly what's going on to help troubleshoot and debug. And if you're familiar with Envoy, it's not always that easy, maybe using Istio or Consul or whatever, to get this information. But with Gloo, it's fairly straightforward. The last thing I'll show you about working with the proxy here is I believe I thought it was under under proxy, let's see, debug. Where is the is that? Yeah, dump. The dump command will show the actual running Kubernetes or Envoy configuration. So we saw some of this in the previous talk. This is the actual Envoy config that's being run, and you can check that out live, so that if there is some difference, so something's not working right, you can go to Envoy itself, say, give me your config. I want to see the config exactly, and then see what's happening with the proxy. Gloo can also, we can get our upstreams. Upstreams are the services that we've automatically discovered. We can see we have, here's a handful of the defaults. What I'm going to do here is do Kubernetes apply. Let's go here, cube, apply the pet clinic, pet store. We're going to see another feature that Gloo does that isn't very common across API gateways, especially those built on Envoy. So we just created our pet store service. If we come here and ask Gloo for the upstreams once again, well, these are upstreams that we've automatically discovered, we should see the new pet store service that has been discovered here. But look at another thing that it discovered. It discovered the actual functions running at a particular endpoint, right? So it has this level of service discovery. We can find the host and port, but then when it finds those, it can go a level deeper and say, oh, this is a REST service. We see a Swagger or Open API spec contract here. Or this is a gRPC service. We can introspect the gRPC reflection, and we can build more awareness and more metadata about the services that we discovered. Now, using Gloo, like I said, all the configuration is CRDs. All the configuration is YAML and declarative. If we do what is the thing here? Pet store. Oh, I guess I don't have it. All right. Well, so I don't have the YAML. What we can do is add route to, let's do the upstream thing, get the pet store. I don't write up. Grab pet store. So what we could do here is, I guess I didn't have the YAML route handy here, but we could add a route to Gloo with the path prefix of this, and we can just say send it to this upstream. What that should do is create a new object for us. So now if I do, just using Kubernetes, get virtual service in the Gloo system, we should see this default one. Yep. And we should see it as YAML. So this is how we would actually typically declare it and include it as part of our CI/CD processes and so forth as YAML here. So now that I have that declared, if I get the URL and call this thing, curl that /API/pet, we should see that indeed we can reach our service. And so that's fairly straightforward, it's fairly simple, but we just exposed an API on the API gateway. It's using Envoy here. Now, if we look at a little bit more sophisticated example, let's go over here to here, and let's switch over to this cluster. Gloo demo. If we look at a slightly more sophisticated demo here. Here I've refreshed, should have everything running okay. Let's refresh again. Maybe not. No, it is. Okay. Here we're looking at the UI of Gloo Enterprise. And so this gives a user interface for the Gloo system. It gives you idea of the Envoy health. This is very important because there's a lot of nuance, a lot of battle scars built into this nice little green dot. It looks so simple. But when Envoy is given configuration, it can apply the configuration in all kinds of different orders. Envoy is built to be eventually consistent. So when you apply a configuration to Envoy, you're not 100% sure that you're not going to have errors, because you could. You're not even 100% sure that Envoy won't reject it. So we do track those knacks when it rejects the configuration. We do track when things are inconsistent, and we're able to show that to you in a more user-friendly dashboard. Because when you're deploying and you have a bunch of different envoys running, it's really important to understand what is the state that you're in, especially from a security standpoint. If you apply a security policy and you think it's all good and it's not, that's a problem, right? So you need to know that. We can see our list of virtual services, which I kind of poked around and showed you in the previous, and from the console. We can show our different upstreams. If we look at the pet one, pet store. Oh, I don't have the pet store on this one. All right. Well, again, it would show you the automatic service discovery and endpoint function discovery there. We also have a dev portal that exposes the APIs on the why is it not working? Oh, I don't know. Live demo problem. So in this particular scenario, we have this example application. Let's say it's our Java application. We want to extend it with microservices, maybe written in Golang, maybe written as Lambdas on AWS. So if we click on Find Owners, we can get a listing of owners, maybe. If we click on veterinarians, we see the names and their specialties. But we might want to add a city to this. We want to extend the functionality, strangle the monolith, use a microservice. We're going to do some basic routing here with Gloo. We're going to say create a route, and we'll say that this is going to our vet service, but this is written in Golang. Whenever we call /vet, instead of going to the monolith, route that traffic to the new microservice, and I want to expose this new functionality. So now if I come over here, click on veterinarian, we should see new functionality because we're routing to a different service. We're following the strangler pattern and so forth. We're using Gloo as that conduit to be able to do that. If I click on contact, we see an error. That's not implemented. So let's say we want to do the same thing when we want to do that, siphon off that traffic to a different service. But instead of running in a new microservice that we've written in Go, maybe we want to send it to a Lambda that's written in Node.js. So if I click on the upstreams, we don't have any, we don't have any AWS upstreams. Let's create a new upstream, call it AWS. AWS type of upstream is in US East 1, and AWS credentials to be able to talk to it. And if we watch, give this a second, what we've done here is we've automatically discovered, well, all right, it's not showing it, but we've automatically discovered the AWS upstreams and the Lambdas that are part of that. So if I do get upstream AWS, we see all of the different Lambdas that are running in AWS there. So we can actually, as part of our routing, route directly to the Lambda. So if I come over here, we want to route to AWS. We want to route to contact form version 3. We want to transform the response to HTML. And if I say contact, add that, you see hopefully see the route there. And in our application, if I click on contact now, cross your fingers for me. Oh, damn it. Refresh. Sometimes there's a time delay. Okay. So it takes time for the Lambda to spin up there. If we refresh, we see now we have an implementation built on Lambda. The last thing that I want to show you for the API gateway is we want to secure the demo. We want to secure the gateway, and we want to do that with OIDC. And in this case, we're going to use DEX as the provider. Here's just some basic configuration for the OIDC system. We're going to create that. And then what we want to do is configure our virtual service. So remember I said the virtual service, all YAML. I created the one by CLI because I guess I didn't have that prepared with YAML, but we could just do kube apply on this virtual service. But here we're specifying that we want to use the external auth system and the OIDC components of external auth to challenge. So we can't just go to our application or our API in this case without some kind of identity challenge. So now if we go back and try, let's go under this user. If we go localhost, let's go back to localhost 8080. Refresh. Oh, let's just blame that on the cache. 8080. There we go. So now it's challenging us, right? To log in. So if I add this one, I think it was password, and log in. Now we get to our application as we would have expected. We can click around. We can do the same thing. Now, what if we want to write more fine-grained policies? This is where, something like an API gateway or an access proxy, especially in the zero trust networking environment, becomes pretty important. What if we want to use something like an open policy agent to specify policy restrictions and so forth? Maybe for, it's very, very simple admin, we can allow anything, but for a user at example.com, we're not going to allow you to go to /owners on this API. And we can get very, very fine grained with this policy enforcement. So if we do that, apply that. So now we're using Open Policy Agent along with OIDC. So if I come over here, let's get out of this private tab. Let's come back to the private tab. Localhost 8080. Let's log in. Now this time with user at example.com. Password. Log in. Now we get to our application again. But if I click on owners, we shouldn't be able to get to that page. Click on owners. Oh, did I do it wrong? Did it not get applied? Oh, we didn't actually apply the virtual service. All right, very good. Now we did. Now if I click on vets, that should work. If I click on owners, it should be blocked. Yes, it's blocked. So that's the difference of the API gateway. That's the difference between something like Gloo and Contour, and I would say Istio Ingress Gateway, which is also just a vanilla Envoy, that you can do these more powerful access proxy type solve these edge problems a little better. Now, on the Gloo documentation, I left this pop up down here. On August 13th, I will be doing a webinar on federation. So how do you take multiple of these Gloo deployments, potentially across multiple clusters, multiple clouds, multiple footprints, and how do you get them to be smart with respect to each other? How can you configure them from a central location? How can you enable things like failover between the proxies in a smart way? And I'll be talking about that. I am prepared to demo that right now, but I'm running out of time, and I want to leave some time. The last thing I'll point out is again, the Gloo docs, a lot of good information about some of these patterns for deploying proxies as either API gateways or as domain boundary gateways, and all the way down into service mesh. So Gloo plugs in and replaces the Istio Ingress Gateway, so it plugs in very nicely with the service mesh, and it all aligns. The way that we think about it, like I said, all aligns with if we can get this with this model, right? We have federation for the edge, federation for the service meshes, and developer portal built on top of it. Let me show you the edge, or so the service mesh federation is an open source project here called Service Mesh Hub. So definitely go take a look at that. And I would love to, if depending on your schedule and so forth, I'd love to come back and do a presentation on service mesh, Istio, continue the story here, and show any demos about that. But so with that, I'll pause. I'll either solicit questions, or I know Nipandra, you wanted to you had some things to finish up.
There's a few question there on the chat. Like this question about, is there any upper limit for RPS and TPS with the open source Gloo API gateway?
Is there a limit on the
TPS limit with the open?
So performance wise, they're the same proxy. They're the same proxy. Your TPS or latency or any of the performance variables will depend on your use case always, right? What are the size of the messages? What are the authentication and rate limiting policies that you've enforced? And those can vary quite wildly. So I can tell you with certainty, we've used Gloo. So from an enterprise to community perspective, there's nothing different in the proxy that from a performance perspective. What I can tell you is that with Gloo, we have replaced successfully legacy API gateways like an Apogee and some of those other ones in that category. To the extent that the performance you see from Gloo is so significant that with the same infrastructure that they were using to run Apogee, this is a large financial institution, they use 1/5 of that infrastructure to get 10 times better performance than they saw with those legacy API gateways. So Envoy is very performant. We are very performant and security conscious company. So those things. But to answer the question between enterprise and open source, the proxy is the same.
Thanks, Christian. There's one more question on the chat here. Gloo and Istio are both built on Envoy. Gloo is an API gateway and Istio is qualified as service mesh. Are there any major features, functional differences between the two?
Yes. Okay, so first of all, that's correct assessment. That Gloo is an edge gateway. Istio is a service mesh. They are not the same thing. They happen to use Envoy. Like I said, Envoy can be used in very versatile different frameworks. And that's what we're seeing here. And because they both use Envoy, there are some similarities, right? They use Envoy, the same functionality. But if I come over here to maybe this slide will make it a little bit more clear. There are things, like I said, there are roles that you solve with the API gateway. So I started getting at this, right? That the API gateway is a abstraction. It's not just a pass-through ingress, right? It's an abstraction. We abstract away the details and we expose the API a certain way. The whole process around how people find it and so forth and so forth. On the, what are the overlap? Since they use Envoy, well, they both have the same traffic control. They have telemetry collection. They have the ability to do some similar RBAC and policy enforcement and so forth, TLS. But at the edge, there are things that you need to solve for, like OIDC, like web application firewalling, message transformation, and these types, rate limiting, these types of things that are not in Istio. Or if you want, and you'll see this, because if you take Istio today, take Istio 1.6, and you deploy it, and you deploy the ingress gateway, you have awesome ingress capability, right? But you don't have OIDC. You could cobble together, there's some experimental projects out there. You could cobble it together. You can use the Envoy filter CRD, which is alpha, by the way. And you could probably make it work, but it's not built. It wasn't designed, or it's not doing that. Istio is not doing that. Web application firewalling, that's something that we've built into Gloo that is running in the proxies based on mod security. It's not in Istio. Transformation, not in Istio. Rate limiting, again, you can cobble something together. Some of the existing plugins around security, like HMAC validation, this kind of stuff, not. So these are things that you need to solve at the edge that you won't have typically in a service mesh. Now, that doesn't mean one is better than the other. What that means is they both work harmoniously to solve the problems of connecting applications in this cloud environment, but just in different roles.
Yep, thank you. There's one more question. So can Gloo also replace Google Anthos?
So
Or-
Google Anthos solves a slightly different problem. It can be used on Google Anthos, though. Gloo can be used on Google Anthos. I think we have a
So Google
added
Anthos hybrid, connecting your local infra with the cloud. So I think on top of Edge, you can connect, use Gloo maybe.
I think we have. Do I have that announcement? I don't have that announcement, but we do have a partnership with Google. You can run Gloo on top of GKE on-prem, Anthos, in the public cloud, anywhere. I would say that they're solving a slightly different problem. They're not federating at the API gateway level. I don't believe they're federating at the service mesh level. They might start to do that, but I mean, I think we're quite a well ahead of them with Service Mesh Hub. So I'm not exactly sure. But from an API gateway level and the stuff that we talked about squarely today, no, I don't believe that it overlaps, but it can be used on Anthos.
Okay, thank you. There are some questions on the Google, the YouTube live as well. Let me just check there as well. Yeah, the one question is, if we want to add our own routing logic, how is it possible?
Add your own routing logic. How exactly is that? Can you clarify? Because if we go here and we look at
like in addition to host path basically is saying that in addition to the host-based, path-based, I want to add my own routing policy. That's the question on there.
Like what?
I don't know the answer. I mean, let's
come
back to
I would encourage the person who asked the question to come in and look at our docs, so we can do a tremendous number of different routing policies. We can change the message. We can add headers, remove headers. We can give direct responses and rewrites and all kinds of stuff. So, but if there's a specific use case that you're asking about, then like I said, definitely reach out to me. Either on Twitter, or my email is my first name, Christian, @solo.io. So reach out to me that way, and I can help with that.
Yeah, so he came out like, let's say, geolocation.
So geolocate, that's a very good question. That is something that we do in our federation policy. So with the federation, basically what happens, oh crap, I actually have to drop. I have a customer meeting right now, but please reach out to me. I will be happy to come back and happy to address these questions. But geolocation, locality aware load balancing, all of these things we address in Gloo Federation. In the doc right here, I believe there was a Gloo Federation. Maybe in here, Gloo Federation. You can take a look at that. We just announced it a couple weeks ago. But I appreciate you having me. I have to jump. Please keep me in mind next time. I'd be happy to come talk about.
Sure. I think we'll let you go, Christian. Thanks for your time here to join us for this meetup, and the demos were really cool. I really like them.
Thank you.
So hopefully the team also like that. So I'll quickly share the demo of that WordPress is working now. So people can stay here if they want to, but I'll have you leave, Christian, if you have to leave.
Yep. I appreciate
it. I'll see you around, and thanks again for joining in.
Thank you. Thank you all.
Thank you.
Take care.
Thank you. Let me share my screen. I'll just go over the demos which I had, and then if you want to kind of see that one, right? So yeah, let me just quickly show this demo here. There would be just like a couple of them which I may want to share. Yeah, so let's go over the presentation which I was kind of having towards the end of the session, my session, right? So I want to kind of show this is a very nice demo which I did not find anywhere. I kind of built from the scratch there. So what we are saying is I want to deploy a WordPress app, and in the WordPress app, I would like to have what do you call, my analytics come that how much kind of what do you call it, how many connection I'm having and those kind of stuff there, right? So typically we deploy the WordPress app and we get it, like just get it running there. But for example, I want to get the metrics of my MySQL thing, like how many connections I'm having on MySQL, what is the number of query I'm doing per second and so on stuff there, right? So how we can get that thing working here, right? So what I have done is, let me quickly go back and show that. So here I have this Docker compose, which I'll just quickly open it. So in this, we have configured an Envoy, which would kind of help us come inside our environment there. This Envoy. Then we have a database, which is MySQL, WordPress, what we have. Prometheus for collecting the metrics from my Envoy, and then Grafana is to visualize them, right? Now what I have done is I have configured this envoy.yml file. In this file, I'm defining two listeners, as I was showing you there. There will be two listeners there. One is for your HTTP traffic, which is for my blog, and other is for MySQL, right? So that's my two listeners here. This is for my MySQL. This is for my WordPress app. So from the WordPress app, when my traffic is going to come on port 8080, I'll go and hit my blog cluster. That will take me to the WordPress service here. That will take me to the WordPress service. And from that WordPress, if I kind of look at Docker Compose file, so what I'm doing is from my WordPress, I would want to communicate to my database, right? So I'm saying here, don't go via the database. So like here, if you look at this line number, I'm not communicating to the database service here, DB service. I'm saying that go to Envoy 3307. So what I'm saying is come back to the listener 2 here, and from there, the traffic coming, correct? That's how it is going. So let me kind of quickly show that, okay, it's working there. So let me now access my WordPress here. I'll bring that particular presentation here. Yeah. So as you can see that this is my local host. Just a minute. This is my local host serving on port 8080, and from there I'll kind of try to kind of install my WordPress here. I would give my this thing here, represent the Envoy demo. Some username I want to give, and I'll copy, remember this password with me. I'll just copy it. I'll give my email ID, and that's all fine. Install WordPress here. So what this is a typical WordPress has installed there, right? But let's kind of go there. Finish. Come on, yeah. So as you can see, it's installed, and I can now log into my WordPress here with this admin and this here. Okay. Now what's happening is along with the thing which I said, I've also installed Prometheus here, right? So I will now go to the Prometheus and look at the stats there. So I'll kind of say localhost port 9090. This is where I'm going to get all the metrics of Envoy and MySQL and so on here. So if you look at these metrics should be coming here. Yeah, those are coming here. Let me search for MySQL. So you can see that, okay, I'm going to see query passed like this one. It gives me that how many queries has been passed in that thing. So it's like I have passed that 1059 queries there, that number of queries in passed. What we have also done is we have configured a Grafana with that. So what's here? So if I kind of 3000 type, yeah. So that's there. Let me log in here. Admin. Don't close. Yeah. So I'll just give a new password here. It's going to give me the dashboard, which is configured. I had configured by default for MySQL here. So as you can see that now I'm going to see the queries passed per second here. Correct. So if I kind of go back to my thing, I'll create a new blog post here. Yeah, so I'll just write some stuff here. Test one, two, three, whatever. Let me just make it publish. Yeah, so we'll publish that. And then if I kind of go back to my Grafana, and where is it? It logged me out. Okay, anyway. If I log in back here, so here you will see that I'm going to get the new data as well, which I have just used the MySQL for. So here, what I've seen is the demo of a MySQL filter. So as you can see that we are not kind of doing anything special here. What is just that you kind of just put Envoy in place, and that kind of takes care of things for you. So similarly, you can kind of look at other demos as well. So if you want to kind of quickly see, I'll just quickly run the demo for the trace thing also. That would kind of give you some more info here. So let me just make it down here. MySQL one. I really don't know what happened at that point of time. It just this sometimes the demo are not with you, right? That's all. It's going to take some time. I'll not want to kind of hold you guys back. So what I'll do is I'm going to kind of record this entire thing fresh, and then I'll send across the thing for you guys. So that's something which I would do it maybe in a couple of days, and have you kind of try that out on your own. Hope this is useful. I know this is kind of a bit advanced topics, and then but they are really what we need in production and so on these days, right? So hopefully the session was useful for you guys. I'll see you soon in the future meetups there. Okay. Thank you guys. I'll see you soon then. Bye bye. Screw it up.